Hello everyone, welcome back. We have another question to solve today, and the question we are solving today is on trigonometry. Now let's go solving this question. We are given proof that the square root of this is equal to cosec x plus cot x. How can we solve this question? Normally we can go from either side. We can actually move from the left hand side and show this, and at the same time we can move from the right hand side and show this. So what we need to do now is that we want to prove that left hand side is equal to right hand side. How can we do it? Moving from the left hand side to the right hand side now will actually be very simple for us. But if you decide to move from the right hand side to the left hand side, it will somehow look complex, and that will lead to something that will be very difficult, and we need to go with something that is a little bit easy. Now, how can we solve this now? We are going to treat this left hand side term, we are going to treat it like a surd term. So we assume this is the numerator and this is the denominator. So we are going to find the conjugate of the denominator. And the conjugate of the denominator just means we changing the sign here. So we can now multiply the fraction, the numerator and the denominator, by the conjugate of the denominator. This is what I am saying. We are going to have 1 plus cos x all over 1 minus cos x. So we have here now times the conjugate, that's 1 plus cos x all over 1 plus cos x. Don't forget the square root sign. The square root sign is still there. So if you multiply this now, that means that we have for the numerator 1 plus cos x into 1 plus cos x. Then for the denominator now, I will have 1 minus 1 times 1 is 1, minus 1 times this will give us cos x, this times this will give us cos x, while here too we have minus cos x squared. Okay, there is a plus here. So here now we are now going to have minus cos x squared. 1 times this is 1, 1 times this is the one that is plus, while this is minus. So these two will cancel themselves out. Don't forget there is a square root sign here. So here now we are going to have 1 plus cos x square all over 1 minus cos square x. We have cos square x here, so I can still put this square root sign here. But from trigonometrical identity, we know that sine square x plus cos square x is equal to 1. That means our cos square x now will now be equal, or we can as well do like this. Our sine square x will now be equal to 1 minus cos square x. And this is exactly what we have here. That means this 1 minus cos square x now, I can have something like this. And that means that we have 1 minus cos x square all over this one now will now become sine square x. Now let's try and split the square root sign, because if you have something like this, a all over b square root sign is the same thing as having root a all over root b, and that is exactly what we are going to have here. So if we should observe that, then we are going to have something like this. This equation will now be 1 plus cos x square. I have the square root sign here all over the square root sign here, sine square x. I have this. Where do I go from here? This square root sign here, we cancel this square, and at the same time the square root sign here, we cancel this too. That means we are left with 1 plus cos x all over sine x. And if you have something like this, a plus b all over c, this we can actually express this as a all over c plus b all over c. That is exactly what we are going to do here. If we should do that now, we are going to have here 1 all over sine x plus cos x all over sine x. So we are going to have 1 all over sine x now will actually give us cosec x. And here, cos x all over sine x is the inverse of sine x all over cos x. Sine x all over cos x now is tan x. And cos x all over sine x is 1 all over tan x. And 1 all over tan x now is equivalent to cos x. So we have successfully proved the right hand side of this particular equation. That means our left hand side is equal to right hand side. We have proved that now. We are going to stop here for now. I will take it on from here next time. Thank you for watching. God bless you.